If you still remember, yesterday we started solving together exercises, the worksheet related to our lesson, which is Thales Theorem. Yesterday we solved exercise number 1. Did you guys resolve these exercises?
Yes.
Yeah.
So we solved exercise number 1.
Yeah, we solved this yesterday.
Yeah, yesterday, but I'm asking, did you solve again these exercises, Alex? Also, we solved, Alex, we shouldn't hesitate or postpone our work, okay? Please, whenever we finish solving an exercise, you should directly on the same day practice these exercises so that you don't forget them, Alex, okay?
I agree. Sorry, miss.
Bless you, bless you. Now,
Thank you.
Now, we will be solving exercise number 3. Yesterday, we were reading exercise number 3 when our time finished. So,
Yeah.
so again, I just want to see who joined now. Yasmina. Good, Yasmina, that you joined. I think Yasmina joined. Let me see. Okay, so Yasmina and Lana. Yes, Yasmina. Hi, good morning.
Hi, Miss.
Okay, stay with me, Yasmina, please. Yesterday, as I still remember, you started solving exercise number 3. We were reading exercise number 3 to solve, right?
Yes.
Okay, stay with me, Yasmina, and let's again read together exercise number 3. So let's read exercise number 3.
The two straight lines DE and BC are parallel.
Yes.
Calculate X and Y such that AD is equal to 3 and AE is equal to 5.
Okay, so let's look again at this figure, Yasmina. As we can see, can you name please the triangle that we have?
ABC.
Okay, as you can see in this triangle, we have taken a point D on AB, a point E on AC in the same order, right?
Yes.
So after taking the 2 points D and E, we got what he said, that line DE is parallel to line BC. We are given, as you can see, the measure of AD is 3 centimeter. The measure of AB is how much?
AE, Miss.
No, AB. I'm asking about AB in the figure. It's given how much? Look at the figure, Yasmina. AB is how much? Look at this blue line that measures AB. What's the measure of AB?
3.5.
No, AB.
X.
AB is X, yes. We are given the measure of AE, which is 5 in the question. What is the measure of AC, Yasmina?
It's X plus 5.
Yeah, it's X plus 5. We are given the measure of DE, and we are given the measure of BC, which is Y, which is unknown, right? So here in this question, what I'm asked to do is I should calculate X and Y. I should know how much should be X, which measures whom? X measures whom?
AB.
Yeah, so as if he is asking about the measure of AB here, and I should know Y as if he is asking about the measure of BC, okay?
BC.
So here in this triangle, since we have taken D and E in the same order, and we got the two lines DE is parallel to BC, what can we apply here, Yasmina? Yes, start to solve it, please. Since
we apply Thales theorem.
Since what? What do we say? Since line DE,
is parallel to BC,
yes.
we apply Thales theorem.
So this is how we should start. In triangle ABC, since line DE is parallel to line BC, then we can apply Thales theorem. Apply it, Yasmina, please.
AD
Yes,
over AB
yes.
is equal to AE over AC.
Is
Is
equal to.
DE over BC.
So let me write, this is Thales theorem. AD over AB is equal to AE over AC is equal to DE over BC. In the question, again, we should calculate X. So I ask myself, X measures line AB. So if I get the measure of AB, as if I'm getting X, right?
Yes.
Okay, in which ratio do you have AB, Yasmina?
In the first one.
So we should take the first ratio, which is AD over AB. Now, let me look. Should I take the second ratio or the third ratio? AE, do we have the measure of AE, Yasmina, in the question?
Yes.
It is how
5.
much? 5. Do we have the measure of AC in the question?
No,
Look at the figure.
it's X plus 5.
So we have it, it's X plus 5, even if it has an unknown in it. So we have it as X plus 5, right?
Yes.
So which two ratios do we take? The first ratio and the
first.
second ratio.
Yes.
So let's take AD over AB is equal to AE over AC. Now let's replace. What's the measure of AD in the question?
3.
Okay, what's the measure of AB?
X.
What's the measure of
So
AE? Yes, we write X. What's the measure of AE?
X plus 5.
AE.
Oh no, it's 5.
What's the measure of AC?
It's X plus 5.
So we write this. AD is a 3, AB is X, AE is 5, AC is X plus 5. As you can see in this equation, we have only one unknown, Yasmina, which is what?
It's X.
So what should we do now?
Cross multiplication.
So we cross multiply. Start cross multiplying.
5x.
5x.
Equal to 3x
3
plus-
multiplied by x plus 5 is a 3x times plus 15, right?
Yes.
So now we have an equation with the variable x. I get all the variables to side 1. I leave all the numbers to side 2. This is how we solve an equation, right?
Yes.
So 5x minus a 3x is 2x is equal to 15. Now the variable x is equal to 15 over 2, which is 7.5. So I got x. I got the first variable x. I have known the first variable x, which is 7.5, right? Thank
Right.
you, Yasmina. Thank you. Now I want to ask, please, Aline. Yes, Aline.
Yes, miss.
Okay, we have got the value of x, Aline, which is 7.5. Now I should get the value of y. Whom does y in the figure represent?
BC.
Okay, so in which ratio do you find BC?
The third one.
So we should take the third ratio. As I said yesterday, Aline, if you still remember, if I take the third ratio with the first, it is similar to if I take the third ratio with the second. Why? Because the three ratios are equal to each other. So it's up to you to take any ratio. But I can see that the easiest ratio to take with the third is the AD over AB, because I know AD and I know AB, which is X, which is 7.5, right?
Yeah.
So we take the first ratio with the third ratio. Now let's replace. We replace AD by how much?
AD is 3.
AB is how much?
AB is
It is x.
7.5.
Yes, so it is 7.5. We replaced it because we have got x here. We replace DE by how much in the figure? DE
0.5.
3.5. And we replace BC by how much?
Y.
Yes. So this is how we replace. We got this equation now. How can we solve this equation, Aline?
Cross multiplication.
So we cross multiply 3 times y
3y.
and we multiply 7.5 times the 3.5, we get 26.25. So we get the value of y by solving the equation. So this was our third question. How was this question, guys?
Good.
It was simple.
Good, easy.
It is easy, right?
It was good,
Yeah.
mate.
Yeah.
Okay, so now I have Mahdi, he joined. Who else joined while I was talking? Mahdi and whom? Only Mahdi, okay? Okay. So if you don't have any question until now, we can move to question number 4, okay? Anybody has any question, guys?
No.
No.
Okay, so let's move to question number 4 now. Question number 4, we have in the adjacent figure, I want to hear Mariam reading. Please read, Mariam.
Okay. In the adjacent figure, CE equal 12 centimeter and CB equal 8 centimeter, AB equal 7 centimeter, BD equal 3 centimeter.
Yes.
Number 1, calculate BE over BC and BD over BA.
Okay, so we should calculate, he gave me 2 ratios. I should calculate the first ratio and the second ratio, okay?
Yes.
Mariam, are you still with me?
Yes.
Okay, let's look again, Mariam, at the given figure here. So we have this adjacent figure. We have the value of segment CE, it is 12 centimeter. So this segment, which is CE, it is 12 centimeter. We have CB, it is 8 centimeter. We have AB 7 centimeter, and we have BD 3 centimeter. Now we should calculate BE over BC. Do you have the value of BE, Mariam?
No.
Can you get it? Can you find it?
Yes.
How much is BE?
BE.
How can we find BE?
Miss, can I answer?
We have CB 8 centimeter.
Yes. And CE is how much?
12 centimeter.
So how can you find BE?
So write 12 minus 7 equal 5. 5 centimeter.
Why 7? You said that BC is 8. Okay, please look here at the figure, guys. I have the measure of this big line, this segment, which is CE. On segment CE, we can see 2 segments. We can see segment CB and segment BE, right?
Yes.
If I have the value of CB, it is easy to calculate BE. Why? Because this small part, which is BE, is CE, the big part, minus CB. So how much is CE?
12.
How much is CB?
8.
So 12 minus 8 is?
4.
So BE will be how much?
4 centimeters.
So we replace BE by 4. And we replace BC by how much?
BC 8.
8. So 4/8, always we should reduce the ratio. We reduce by 4, so we get 1/2, which is 0.5. So the ratio BE over BC equals to
Equal
0.5.
to 0.5.
Okay, Mariam?
Okay.
Okay, thank you, Mariam. Now I want to ask Yara. Yes, Yara.
Hi, Miss.
Hi, let's calculate the second ratio, Yara. BD over BA. How much is BD given in the question?
BD 3 centimeter.
How much is BA or AB?
AB 7 centimeter.
Listen, Yara, if I read it BA or I read it AB, it is the same. If I read it BC or CB, it is the same. It's not a different segment, okay? Keep this in mind, please.
Okay.
So we replace BD. So this is how Mariam calculated BE, which is 4. As Yara said, we replace BD by 3. We replace BA by 7. So if I divide the ratio, I get 0.42. So BE over BC is 0.5. BD over BA is 0.42. So we calculated part 1. This is how we calculate ratios. We should replace each length by its value to get the value of all the ratio at the same time. Did you get how we calculate ratios alone, guys?
Yeah. Yes,
Okay.
Miss.
Yeah.
Now in part 2, he is asking me, are the two lines AC and ED parallel? We should justify. So again, are the two lines AC and ED parallel? So are these lines AC and DE parallel to each others? I don't know. We should say, if they are parallel, we should say, why are they parallel? If they are not parallel, we should say why they are not parallel. Since here we are studying Thales theorem, let me go back to what we discussed before. If you still remember, when we discussed the lesson, which is Thales theorem, we said that if I applied Thales theorem, I can apply it because I will be given parallel lines. So because I have parallel lines, I can apply Thales theorem and I can write ratios, right, guys?
Yes.
Okay.
Yeah.
Yes.
Now I don't have parallel lines. Let us go back inversely of Thales theorem. If I can prove ratios, I can apply Thales theorem, so my lines would be parallel. Again, Thales theorem is, I have parallel lines, I can apply Thales theorem, I can write ratios. Now, I don't have parallel lines. I should prove parallel lines. So I start opposite to Thales theorem or converse to Thales theorem, which is if I can prove equal ratios, then Thales theorem is applied, then my lines would be parallel. This is what I discussed in the converse of Thales theorem. So always to prove two parallel lines, we can prove these parallel lines using the converse of Thales theorem. What is the converse again? If we can prove equal ratios, then my lines would be parallel. So here, did we calculate before ratios or we didn't calculate ratios?
We calculated ratios.
Let us repeat the ratios that we calculated together. We calculated BE over BC and we calculated BD over BA. Are these two ratios equal to each other?
They're not.
Okay, so by converse of Thales theorem, my lines DE and AC, are they parallel?
They're not parallel.
So because the two ratios that I calculated are not equal, then we say by converse of Thales theorem, the two lines would not be parallel. This is how we write it. So BE over BC, is it equal to BD over BA? So I should see if these two ratios are equal to each other's. We calculated BE over BC is 0.5, BD over BA is 0.42. Are these two numbers equal? No. So we write false. They are not equal to each other's. So we say by converse of Thales theorem, the two lines AC and ED are not parallel. Any question about how we apply the converse of Thales theorem, guys? This is how we apply converse of Thales theorem in order to prove two parallel lines. Any question?
No
Guys,
questions.
I want to hear
No.
you talking. It's not me. It's not only me the one talking here. Please, guys, when I ask you a question, respond. So this is
I don't
how.
really have any questions, miss. I found this pretty easy.
Okay,
Since
so
it's really just like if you did the ratios and you should be easily able to do it. You just copy and paste
yes.
your answer from
So we should know, Alex, a very important thing here, which is always to prove two parallel lines, we might be using Thales theorem, the opposite of Thales theorem. How do we use the opposite of
Converse.
Thales theorem? Yes, the converse. How do we use the converse of Thales theorem? Proving
well, to use
two
the
equal ratios, it's only enough to prove two equal ratios. We don't need three
course.
equal ratios to each other's. Any two ratios from the figure equal to each other's, then the lines will be parallel. If the ratios like here are not equal to each other's, then the lines would not be parallel. Okay?
Of course, miss. So as long okay, never mind that.
No, ask me, Alex.
So as long as we did the ratios and then we get asked the question of are x and y parallel and justified, then if we did the ratio question first, we can just do the same thing we did here, right?
Yes.
Will
the
this
same.
mean the exam or will there be a harder version?
Now we will see another version of applying the converse of Thales theorem. But this is the
Okay.
base. This is the base, Alex. If you understand this, you can apply it in any other question.
Okay.
Okay, let's see another question. Let's look at exercise number 5. We are given a figure. In the following figure, the points K, A, F, and C are collinear. What do we mean by collinear? They are on the
On the
same
same
straight,
line.
yeah, on the same line or on the same straight line. Also, the points G, A, E, B are collinear. So these 4 points are collinear and these 4 points are collinear. Can I ask you a question, guys? The line BE and the line FC, where do they intersect? The two lines BE and FC,
A.
at which point do they intersect?
At A.
Yes.
Point A.
Yeah, they intersect at point A. Let me continue. EF, line EF is parallel to line BC. So by given we have EF is parallel to BC. AB is equal to 5 centimeter, AC is equal to 6.5 centimeter, AE is equal to 3 centimeter, EF is equal to 4.8 centimeter, AK is equal to 2.6 centimeter, and AG is equal to 2 centimeter. We are given this length that you see here. In question number 1, show that BC is equal to 8 centimeter. As if he is asking me, calculate BC. After calculating BC, what should be its length?
8
It should be 8.
The length of BC should be 8.
is 8.
So he gave me the length of BC so that I can make sure that what I did is correct. So we should calculate the length of BC. Who are the two parallel lines in this figure, Reem?
BC و FE.
Okay, so we have line BC is parallel to line EF. They intersect here, the two lines intersect at E.
At A.
Sorry, at A. Okay, Reem, can you apply Thales theorem because you have parallel lines? Can we apply
Yes.
Thales theorem in this figure?
Since BC is parallel to EF,
Apply Thales
apply
theorem, Reem.
ratio.
Yes,
Yes.
apply it, please. Don't panic, Reem. It's very easy. Here we have the big triangle ABC. Look carefully, Reem.
Okay.
We have a triangle ABC and we have a triangle AEF. Do you see the big triangle and the small triangle up?
Yes.
Here, as if Reem, I have taken point E on AB to the right side, and I have taken point F on AC to the upward side. So here I have this small triangle and I have this big triangle. Why? Because these are the two parallel lines. So it's easy now to apply Thales. Start applying Thales, Reem. So we say AF
AF
over AC
over AC
is equal to
EG.
No, listen, Reem. We take the sides of the small triangle over the sides of the big triangle. We started AF over AC. Take the second side is equal to AE over AB. Take the third side is equal to
equals FE over BC.
Again, Reem, please repeat it.
Okay. F
No, start with A.
AF
Over
AC
yes,
is equals to AE over AB
is equal to
FE over BC.
Okay, whenever you are given two intersecting sides, Reem, and you have two triangles, one downward and one upward, it's easy. Take the first side in the first triangle over the first side in the second triangle. Then start with the first triangle over the second triangle, the first triangle over the second triangle, okay?
Okay.
So this is how we apply Thales theorem. I should get the value of BC. So I ask myself, Reem, in which ratio do we have BC?
BC, the third ratio.
So we take the third ratio. Let us decide which ratio do we take with the third to calculate BC.
AF over AC and EF over BC.
Yes, why? Because we have the value. Do we have in the question the value of AF, Reem? AF, are you given AF?
No.
So it's hard to use the first ratio. Let's look at the second. Do we have the value of AE in the question?
Yes.
The value of AB, do we have it?
Yeah.
Yes.
So we take the second ratio with the third, okay, Reem?
Yes.
Now let's replace. AE is a 3, AB is 5, EF from the question is 4.8, and BC we leave it as it is because we are calculating BC. Now what do we do, Reem?
Cross multiplication.
We cross multiply. 3 times BC is
3 BC.
and 5 times 4.8 is 24. So BC is equal 24 over 3. Then BC is equal to 8 centimeter. It is similar to what I want to prove, right?
Yes.
So BC, I showed that BC is equal to 8 centimeter. So here he asked me to calculate BC in another way. He didn't say calculate BC. He said, show that BC is equal to 8 centimeter. So we used or we applied Thales theorem in order to show that BC is equal to 8 centimeter. Okay?
Okay.
Thank you, Reem. Now, question number 2, we should read, are the straight lines KG and BC parallel? This is KG and this is BC. I should prove of if these two lines,
We use
Alex,
the
are
converse,
parallel.
right? We use the converse, yeah.
Okay, which triangle do you take? KG and BC are in which triangle, Alex?
KG and BC are in the ABC big triangle.
So we take the big triangle ABC. We say, Alex, we have taken triangle ABC. So I should prove if KG is parallel to BC. صح, right, Alex?
Yeah, so if KG is parallel to BC, so
What
first
ratio,
we need to,
what ratio should we prove here? Can you say the ratios, Alex?
we already have the ratios, no? Wait, 3/5
No,
equals,
Alex. No, Alex. These ratios, we applied them in EF parallel to BC. Now, forget about EF and BC. We should prove if KG is parallel to BC. Let's see which ratios can we make in this triangle, Alex. A, B, C. Which ratios can you apply here to prove the converse of Thales?
we could make AG over AB and AK over AC.
So AG over AB, is it equal to AK over AC? Is it
We'll
equal
see.
to KG over BC? So we write these ratios.
Yeah, we
Now,
should have given.
okay, by given we have AG, right?
Yeah.
We have AB, right?
Okay, let me see in the givens, trying to find AG is 2 centimeters.
AB,
And AB is 5 centimeters.
AK,
And AK is 2.6 centimeters.
AC.
And AC is 6.5 centimeters.
So we should prove if these two ratios are equal, then the lines would be parallel. So as we said, Alex,
we can already see that they're not equal.
Alex, let us replace, don't see vague like this. So if I replaced AG over AB by 2/5, I will get 0.4, right?
Yeah.
So let's replace AK over AC. AK over AC is 2.6 over 6.5, which is also 0.4. So are the two ratios equal to each other's?
Oh, it is.
Yes. So by converse of Thales theorem, because my ratios are equal to each other's, by converse of Thales theorem, the two lines GK or KG and BC are what?
Parallel.
Yeah. So don't see something, Alex, before you calculate. You should calculate the value of the ratio. Then you should decide if they are equal or not. Okay, Alex?
Yeah, you're right, miss. It's always better to
It's always better to take time while thinking and calculating. Okay, Alex?
especially with geometry.
Yes, this is not hard geometry. This is a very simple geometry. It's not hard. It is only a matter of writing ratios and calculating. That's it. Is it hard, Alex?
No, miss, it's not hard.
Okay.
It's actually pretty.
Okay, thank you, Alex. Now let's move to question number 3. Are the straight lines AC and AB perpendicular? Who can tell me what do we mean by perpendicular? What do they form in between if they are perpendicular?
90 degrees.
At which vertex should be the 90 degrees?
A.
At A.
Say.
So if we can prove that angle BAC is equal to 90 degrees, then they will be perpendicular, right?
Yeah.
Okay.
Yes.
Yeah.
In which triangle are the two lines AC and AB, guys? In which triangle?
ABC.
Can we prove that this triangle is a right triangle? Using which theorem can we prove right triangle?
Maybe using the midpoint theorem.
What did you say, Kalam?
Well, I guess we can use the median segment if that makes sense, because like that's only applies on right
Do
triangles.
we have median segments here?
No, we don't have.
We have the length of AB, we have the length of
Yeah.
AC, and we have the length of BC. So which theorem can we apply here, Kalam, if we are talking about length?
Oh, length. Maybe the Pythagoras theorem, right?
Yes, we can apply the converse of the Pythagorean
Yeah,
theorem.
the Converse. Yeah.
Okay, AB is 5 centimeters, so AB squared is 25. AC is given 6.5, so AC squared is 6.5 squared, which is 42.25. Let's calculate the third length BC. BC is 8.